All right, the video just keep rolling for this one section. Again, this is going to be probably the longest section we do, so don't expect all there to be like 8-9 videos for each one. So let's jump into it. We're going to get away from the whole unit circle thing. We're just going to talk about triangles. So hopefully you've heard this before. It's called SOHCAHTOA. SOHCAHTOA. Or we could write it like this. And what this is a little acronym telling you that sine of an angle is the opposite O over H. The opposite over the hypotenuse. And down below, we give an example. The opposite is the side opposite the angle. The hypotenuse is the longest side, and the adjacent is the one that's touching the angle, but is not the hypotenuse. So sine is the opposite over the hypotenuse. It's just a ratio. You give me an angle, I pop it into sine, and I can tell you what the ratio of the opposite to the hypotenuse might be. Similarly, we have, whoa, come on, dude. We have cosine, and it says A over H, so that's the adjacent over the hypotenuse. And tangent is going to be our opposite over the adjacent. That's the OA. So they give us 3 different ratios. Now there are what we call our reciprocal functions. Cosecant is just the reciprocal, the flipped over. Flip over your fraction. So it's the hypotenuse over the opposite. Secant goes with cosine. Doesn't that suck? The S goes with C and the C goes with S. Yeah, well, that's just the way it is. So we'll just take whatever cosine is and we just flip it over. Just flip it over. That's why we don't spend any time memorizing cosecant, secant, or cotangent. We spend all our time memorizing sine and cosine, and then a little bit of tangent. And there we go. Because as soon as I find sine, cosine, and tangent, shit, you get cosecant and secant for free. So let's just draw up a triangle. Let's see if we can't play some games. No angle at all. Where's it going to be? Hey, there's some angle in there. Maybe it's 20 degrees. Maybe it's 50 degrees. I don't know what the angle is. It doesn't really make any difference. Now let me just pop in some numbers. Let's make this 2. And actually, let's keep it mellow. Let's keep it mellow. Let's make this side 3. This side 4. It's a right angle. So 3 squared plus 4 squared is 9 plus 16. That's 25. And the square root of 25 is 5. So whatever. We're here. There's a triangle. It's called a 3, 4, 5. Very common triangle we have. So then we wonder, we're like, well, what's sine, cosine, tangent? What's all the 6 trigonometric functions? So we're like, well, sine of theta is going to be our opposite, which is 3 over our hypotenuse. 3 over 5. Cosine will now be our adjacent over our hypotenuse. 4 over 5. Now, there's a trick you can do. Now, of course, when you have the triangle sitting there, you're like, well, I can just look at this and go, it's the opposite over the adjacent. But notice, it's the numerator of sine divided by the numerator of cosine. That's always going to happen. We get 3/4, or you can just look opposite, adjacent. Now, what I was meaning before with why you wouldn't want to spend any time with cosecant and secant or like memorizing any values is there's no need for it. As long as you know cosecant is the reciprocal of sine, all we're going to do is take 3/5 and flip it over and call it 5/3. Secant, same thing with cosine. You're just going to take cosine's 4/5 and you're going to flip it over and call it 5/4. And lastly, we have cotangent, which is just going to be the reciprocal of tangent, or 4 over 3. So this is going to be how we can solve right triangles. Right triangles, man, they're dope. They're good. They're not so bad. We can handle right triangles. Just sometimes with this whole unit circle idea, it can get a little bit confusing. So this is going to be our game, and we're going to start to take these, this little preview. Make a little shape here, a little XY. We still have our, 0 degrees, 90 degrees, 180 degrees, 270 degrees. It goes back to 360 degrees. But now we're going to start to take some triangles. Like maybe we take this triangle and we put it in. And we're like 3, 4, 5. But notice if this is a circle, it's no longer the unit circle. It's a 5-unit circle because the hypotenuse is 5. So we're not always going to deal with the unit circle. We're going to deal with 5-unit circles and 7-unit circles, 12-unit circles. But we start with a 1-unit circle just to get some ideas down. But that's going to be the game we're going to do. And then we're going to be able to take these triangles and say, hey, you see this 3, 4, 5 triangle we created? What if we put that triangle down here? What if we put it inside of here where this is still 5, this is 3, and this is 4? What's going to end up happening is we're going to look at our x values. See that this is an x value? It's going this direction. Is that the positive or the negative? It's actually negative, and that's negative. It's going to be weird and wacky, but we're not there, and that's not what we're doing yet, but we will be there soon. So there's our beginning, and then I'm going to build our 2 triangles, our 2 common triangles with some values that we must have memorized. Not written down to where we can look at, but memorized. I'm going to try and get you a way to get this real simply where you can get them all memorized up with a minimal amount of work, just knowing 5 numbers. So I lied to you last time. We're not doing the 5 numbers. And this one, we'll do it in our next video. Yo, buddy. Hopefully that makes sense. But all we're trying to get here is SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite over the adjacent. Knowing where an opposite and adjacent and a hypotenuse are on a triangle, very good. So, all right, we'll build triangles in the next ones. We'll do our commons. See ya.